Hello everyone. Welcome to my channel. In today's video, we will learn about explicit dynamic simulation in Ansys by using a moving bullet and a fixed plate. So let us quickly dive into the video. I have already opened Ansys Workbench, and on the left-hand side panel you can see the list of all types of analysis. We need to activate the explicit dynamic simulation. So drag it and drop it on the right-hand side inside this red box. Now, a box will open up here. First we need to import the CAD geometry. For that, right-click on Geometry, then go to Import Geometry and then select or browse the file from its location. After that, right-click on the model and click on Edit. This will open the workspace where we will set up the analysis. Wait for some moment until you see the imported CAD geometry. We are using the default materials for both the bullet and the rectangular plate, which is structural steel. We are also using default mesh settings, so right-click on Mesh and then click on Generate Mesh. The default mesh looks good. You can refine the mesh for even better results. Now, we will set up the boundary conditions now. Firstly, right-click on Explicit Dynamics. Then select Velocity. Under Velocity Settings, we need to select the whole body of the bullet. So switch the selection to Body Selection this and select the whole body of the bullet and apply. After that, give velocity of magnitude -300 meters per second along the Z component. It is coming out to be in millimeter per second, so change the units to meter per second. Adjust the value again by rewriting it and press Enter. With this we have set the dynamic condition. Now, we need to fix a body which is going to be the steel plate, so again right-click on Explicit Dynamics, go to Insert and then go to Fix Support. Under the settings, only select all the 4 thickened face. For that, switch the selection to Face Selection, and then select the 4 faces, like this, and hit Apply. After this, we need to constrain the movement of the bullet. It needs to travel in a straight line. So for that we need to use displacement, which can be found by right-clicking the Explicit Dynamics. Under the settings, we need to select the edges of the bullet like this. We need to have an edge type of selection for selecting the edges. So make sure you switch it. After selecting the edges, click on Apply. Then give 0 value along X and Y direction and keep the constraint free along Z direction. That's because we don't want the bullet to travel in any other direction. By doing this, the bullet will only propagate along Z direction. Now, we need to go to Analysis Settings and give the value of simulation end time. That means the time required by bullet to hit the plate. You can see the bullet is already so close to the plate and it will be traveling with a velocity of 300 meters per second. So we need to keep our end time very short. I have kept it 5 to the power 10,000. Like this, you can select the values. One thing to note here is that more smaller the value you will keep, longer the time it will take for the simulation to complete. But if you have good computational resources, go for longer simulation to get better and in-depth results. After that, go to the solution by right-clicking and select the parameters you want to evaluate. I am evaluating directional deformation along Z direction. And also the amount of shear stress. After that, hit the Solve button and the software will solve the simulation. In some time the status bar will show up on the screen. I am fast forwarding the progress here, so the simulation is done now. Let's check the parameter results. If you click on the directional deformation, you can see that the bullet has pierced through the plate and has left a hole. You can play the animation also to better visualize. Check for the stress tool parameter as well. So that is how you can also perform an explicit dynamic simulation. It can be used to simulate real-life scenarios like car crash test, explosions, or breaking of glass. I will upload more such videos on other scenarios as well. Thanks for watching. Please like and share this video. Don't forget to subscribe my channel. See you in the next video.